So I'm going to have you guys write down a couple things on the packet here. Okay, so if you turn the page, on page 2, in the middle there, just write down 59.
Can you highlight it too?
No,
Interesting.
Joe, and I'll give you this copy. Right. So 59 at the bottom where it says how to experiment well. 59. And then turn the page to, you're going to write 63 and 65. And then underneath the middle slide there, you're going to write part A and B.
How to experiment well. How to experiment well.
All of this will make sense as we go along. Okay? So we're going to use the PowerPoint slides to give us a chronological order, but I'm inserting different things as we go. You'll also notice that in Canvas is that there's 2 different tests you're going to take for Chapter 4. One of them is a group test, and then the following class period you're going to take a lone test. I don't know about you, but I don't learn Chapter 4 just by reading myself. I have to talk about it and iron things out. So I think the format of a group test will be very, very helpful as you guys get together and talk about it. To clarify, because a lot of the questions are ambiguous, so it really helps to negotiate with a buddy about what you think. All right, turn the page again. So underneath the top slide here, in inference for experiments, we're going to put part C, blocking part D. We're actually going to have a little popcorn reading in here. We're going to read out of the textbook. So I went ahead and read the whole section, and that's those 2 paragraphs or 3 paragraphs are vital. We're going to weave in and out like, yeah. Yeah.
What is the second word?
Amoxicillin.
Oh. What?
So does amoxicillin help sinus infections? It's a 100-year-old antibiotic. Are sinus infections becoming more strong? Because I know, like, sometimes I'll get a sinus infection and the doctor's like, let's try this one, Bactin or something. And because sometimes there's a immunity that you get to that. And some doctors are actually pretty leery about prescribing antibiotics. Anybody have a doctor like that? It's like you go in there like, look, I'm dying, give me something. They're like, well, let's just wait this one out. They're like, no, really, I need something to kill this. It's been 2 weeks. Yeah, so if you go in there and you say, if they say, how long have you had this sinus pressure, and you say like 2 days, they'll send you home. At least my doctor will. So I have lied to my doctor. I feel bad about it. Like, look, it's been 5 months. I'm like, gobs of... Okay, so I can't go forward. Okay, we're like, is there pressure there? Ow! Ow! Don't touch me there. Okay, so does amoxicillin help sinus infections? Your homework is going to be to fill in all this, and hopefully by the end of the day, you're comfortable with this. So you're going to be, this is a template, so make believe that you're a pharmaceutical someone, and you're the person getting paid to answer this question. Okay? So 99% of an experiment is the planning. Okay, 99% of it is the planning. Okay, actually conducting the experiment is literally just pulling the trigger on the event. Follow me? So you're loading the gun, you're setting up the gun, everything, and the conducting the experiment is the easy part because you've designed it so well that you're just executing the plan. You with me? Okay. So got all that written down? Okay. So go back to the first slide here. We're going to zip through a few slides. So on your desktop, you should have your textbook ready. You don't need a graphing calculator today. You actually won't need it for another 3 weeks. Pine cones. Is it responsible?
No.
The answer is no. It's not. Because correlation does not mean causation. And I looked through those questions again, and only 2.5 people in here got that right. So I gave a half a sticker. I took the froggy and tore it in half.
But when you get through the other half,
Because the person said, I need more information. They did not make a judgment. This is, I need more information to see because there's something else going on that I don't know.
Throw the other half away.
Yeah. So the other half is at home. So just let it be known that I don't give out stickers out liberally. So, and then I was telling you that there was the reason why there's other variables involved, and I use the phrase lurking variable, or I also use the word confounding. And as I was reading this section, confounding does not mean that. I use that word in a wrong context. Okay? And this is a section, this is a lesson that nothing is more incriminating than using the wrong term in the wrong context. Right? Okay? And when it comes to Chapter 4 on the UAP Stat test takers, there is very little partial credit for these questions. It's very cutthroat. You use the wrong term in the wrong context, you're saying, I don't understand these terms. Now the mathematics, you forget a negative, you do something wrong with the other questions that are numerical, there's a lot of leeway and a lot of partial credit. But when it comes to sampling and experimentation, you have to know the terms well, use them in the right context. There is no partial credit. You with me? So the fact that I use the word confounding in the wrong context, nobody in here called me on it, but it's humbling for me after teaching this class 7 or 8 years to go, I still am having trouble with Chapter 4. So I'm going to face my fear, and I'm going to teach it for the first time.
Yeah.
Students! All right, so this is the first slide here. I don't know if there's anything that you need to... So, yeah, one of them is exactly what I said. I'll be able to explain confounding correctly. Okay? So these are the check. Describe a placebo effect and the purpose of blinding. So that's a big picture view of the whole section. That's just one section in the textbook. Observational study. That's the second one, right? Now, if we go to the pepperoni analogy here, when you're asking the questions, you're not trying to influence the outcome, right? You're not saying, do you really like techno bagpipe? Like, really? You would not do that to influence the outcome. You're just simply saying, what's your favorite genre of music? You're collecting the data, and you're not trying to influence that. Now, so this is section 4.1, that's section 4.2. 4.2 is the longest section in the textbook, I think. And this is deliberately imposes some treatment upon the individuals. Okay? The third slide here, let's skip that. Third slide. So confounding occurs when two variables are associated in such a way that their effects on the response variable cannot be distinguished from each other. For example, the duckbill bird question, right? And the pine cones. Is there a correlation between pine cones and duckbill pairs?
Yes.
Yes. Does pine cones?
no.
No. Okay. However, food supply and predators would affect duckbill population.
Yes.
Those two variables are confounding in the sense that it's hard to distinguish their effect on the outcome. They're so intertwined, they're confounding variables. It's hard to know which one would be the cause of the response variable. Temperature, climate, food supply, parasites, predators, okay? So those are called confounding variables. Okay? I use it in the wrong context because the question does not address those variables. That does not make them confounding. Very, very subtle difference, but I use it out of context. Okay? Everybody cool on confounding? Confounding? Okay, so I gave you an example of the little birds there. Let's turn the page here. One thing I want to draw your attention to is everybody circle the word smallest collection. Smallest collection. So the one thing looking through these slides that I want to differentiate, and some of the multiple choice questions on this section try to get you to view a experimental unit as something that it's not. For example, you know when we did the flash mob example of the pep rally, one of the type of experiments was to create a cluster, right, of 6 students. That cluster is not your experimental unit. Even the 2-stage cluster where you choose, remember the 2 circle people within the 6? That is not an experimental unit. The smallest collection of things that we're collecting are what? A human being, a person. So a lot of these questions are posed. So just because you have clusters, or a cluster within a cluster, that does not make that the experimental unit. What makes it's you're dealing with people here, okay? And it's real easy to see when you're dealing with people, but you're going to see scenarios today where they're not people. You're going to see scenarios in the future where it's not people necessarily, and you're going to have to discern what the experimental units are. Just want to make a distinction. Cool? All right, turn to page 240 in your textbook. 240. Now, I always appreciated my English teacher that whenever I had a real good English teacher my junior year, turned me on to English. I got an A for the first time in my life in English. Took me till age 17. He would always start out by, instead of teaching us what something was, he would teach us what it wasn't first. The antonym. Okay? So, I want to start out, or actually the textbook does a good job, by showing you what an experiment is not. Okay? And since all of you are fledglings in the experimental world, newbies, noobs, fledglings, I'm just going on with a bird example here. You may read this and go, I don't see anything wrong with this. This looks like a pretty good experiment. But it's real important that you guys see the flaws in a bad experiment. Or the flaws in an experiment, okay? So, if you look at my cool agenda here, section 4.2, experiment, pitfalls, and design. So we're first going to look at the pitfalls. You dig? Right. So would someone like to read the online SAT prep course, or our online SAT prep course is effective? We've got a couple paragraphs there. Would someone like to read?
Our online SAT prep course is effective. A bad experiment. Our high school regularly offers a review course to prepare students for the SAT. This year, budget cuts will allow the school to offer only an online version of the course. Suppose a group of students who take the online course earn an average increase of 45 points in their math scores from a retest to the actual SAT test. Can we conclude that the online course is effective? This experiment has a very simple design. A group of subjects, the students, were exposed to a treatment, the online course, and the outcome, increase in math scores, was observed. Here is the design. scores.
Okay,
But closer-
stop. You gotta see the slide where it says how to experiment badly?
Yeah.
You see how there are 3 grayed out rectangles? Experimental units, students in the textbook, see that? Treatment, online course, and then measure response, increase math scores. And I know that that's mentioned lower below this little tan box here, but the slide has the theoretical. This is a specific example. Okay? So far, I don't know about you, but when I read this, I'm like, what's wrong with this? And you're going to see as we talk about this example, the pitfalls of experiments, okay? So, all right, let her rip.
A closer look showed that many of the students in the online review course were taking advanced math classes in school. Maybe the students in the online course improved their math scores because of what they were learning in their school math classes, not because of the online course. This confounding prevents us from concluding that the online course is effective.
All right, in the lab environment, simple designs often work well. Field experiments and experiments with animals or people deal with more variable conditions. Outside the lab, badly designed experiments often yield worthless results because of confounding. So you may say, what's the problem they did better? They happened to take this online course. Let's just leave it like that. But there are confounding variables that may affect the outcome. So if you're trying to answer the question, is the online course effective or not, you can't just look. Have you ever heard the phrase, the ends don't justify the means? Here, if you're saying that this is a good experiment, you're saying that the end, good scores, affects the means. Cool. All right, we're going to do one more slide, and then we'll take a break, okay? Everybody cool? All right, so pretty much the pitfalls with experiment, what's the statistical word for that? Confounding. So you have to be very careful of confounding variables that may affect the outcome. So the best experiments is where you can isolate variables that exclude everything else and just zero in what you're looking for. So how to experiment well? The remedy for confounding is to perform a comparative experiment in which some units receive one treatment and similar units receive another. Circle the word similar, please. That's on the slide. Most well-designed experiments is compare 2 or more treatments. Similar. Comparison alone isn't enough. If the treatments are given to groups that differ greatly, bias will result. For example, if we do an experiment, let's say me and Connie want to do an experiment. Okay, we want to give the amoxicillin to our friends. Okay, and I tell Connie, hey, I'm going to go to my Boy Scout troop tonight. I never was in Boy Scouts, by the way. And I have 80 boys that are going to be there. I'll give it to them. She goes, oh, well, I have brownies tonight. What's it called?
Girl Scouts?
Girl Scouts. There we go. You haven't graduated from brownies. So she goes, well, I'll just go and give it to my troop. Okay? Now, we're giving it to boys and girls. Okay? And suppose let's say she's a leader for brownies. She's not in brownies, but she's a leader. So she'd be giving it to, number one, a different gender and a different age group. Okay? Our results would not be a good comparison. You follow me? That's why I want you to circle similar units. Follow me? So if the treatments are given to 2 groups that differ greatly, bias will result. Results will result. Okay? So the solution to the problem of bias is random assignment. Random assignment. Okay. So what I'm going to do is I'm going to show you a Molesky video.